Hello, I'm Max Wolf, aka Minimaxer, and today we'll be talking about some fun data visualizations I made using R and ggplot2. And in this particular post, I had a little too much fun with R and ggplot2, and if you read the post proper, it's a little chaotic, which is why I'm doing a little bit of explaining video to make sure to mostly self-check myself, and hopefully you'll benefit from some cool things you can do with R and ggplot2 that you may not know how to do. And I, frankly, am surprised they actually worked. So here I have RStudio open with a mostly complete notebook. I have you can see everything. I just started a fresh session. I have everything written, and so let's get down to business. Here I set up a few R packages which are extremely useful. I start with tidyverse, which has all the data manipulation libraries I need. I include lubridate, which is a date manipulation library. I include tidytext, which does a lot of working with Stack Overflow's tags, and incidentally was created by data scientists at Stack Overflow, I think partially for this incidentally exact purpose. Scales is a formatting library used for percents and commas. Viridis is a palette library, which is a very color-friendly palette used for data visualizations. ggRepel is a text repelling library for use in ggplot, which is hacked to create word clouds. And ggridges is a very new library for use with joy plots, and I'll show those off later. And just in case, I included the brand color for Stack Overflow just for the consistent branding, and that's very important. And in RStudio, you can just click the little play sign to run the chunk, and that's a really easy way for reproducible analysis that's somewhat fun and easy to do in analysis. The first thing I'll do is start off creating the theme for ggplot2, which is based off Source Sans Pro, an open source font which you can get for free off Google Fonts, and it's also the font used on my blog because #branding. Now let's talk about me getting the Stack Overflow data. The data I use is from BigQuery, which is a free data warehouse that you can use to create public data. You get 1 terabyte of query data for free, and this Stack Overflow data is a lot less than 1 terabyte, so it's a very, very helpful data source for this particular project. In this case, I wanted to find the deltas between the snapshots. For example, the this is the March 2017 questions archive, which has features you'd expect, such as question name, question tags, when was the question created, how many points, how many views, etc. And I do a quick join. I use the March archive and then the December archive and find the difference between the view counts of those times to get the delta change between those times in this little subquery. Enjoy them. And then in the outer query, I aggregate by the year in which it was posted using BigQuery's datetime functions and get the total. Since it's created in 2008, it gives a result for 2008, 2009, etc. I download that from BigQuery, and now I'm going to load it into R. I have a file locally, and using Reader, a part of tidyverse, I load a file, and at the same time, I also calculate the proportion of each year by normalizing it, kind of like a pie chart. Although in this case, because it actually goes over the integer limit of 2.1 billion, I have to convert to a numeric, which in R is like a double of the languages. That was a funny bug I ran into. The result is this. You got year, you got the total delta. These are hundreds of years, and also the percent weight, which should sum up to 1 out of these. And now we can do the fun part, which is actually creating plots in ggplot2. Here, ggplot2 is a plotting library that's used for a lot of data visualizations in R, and frankly, if R didn't have ggplot2, I probably wouldn't use it as often as I probably would. But in my opinion, if you're a Python data scientist, ggplot2 is something you should very look into. It might be an edge to learn an additional language. So here, this is the DF deltas. ggplot2, you give it an x and y static at basic implementation, and that you tell what the type of plot you want to make with this x and y static. I'll just do a simple bar chart. It's functionally the same as a pie chart, but pie charts are surprisingly difficult to do in ggplot2. I'll give it a slight transparency with 90% opacity. The stat identity just means ggplot2 will use these numbers instead of trying to aggregate these numbers manually. And then the fill color will be the brand color I included earlier, hashtag branding. Scale X date will date breaks a year with date labels the %y date time format. We'll use the year from this. Keep in mind it's a date, so make sure the date and date match. The y is the percent. It'll automatically convert these to the proper percent for the y-axis labeling. And then, of course, you should, for all data visualizations, you should always label your charts. That's actually kind of important, so don't mess that up. And I say for my ggplot2 workflow, you'll see other data scientists do things differently. I create it as a separate object and save it to disk using ggsave. This is by far, in my opinion, the better workflow because using ggsave will anti-alias the charts and it will look that makes it a lot more portable. This is a separate PNG file. Width 4, height 2, and all these the DPI is 300, so these heights will be 1200 by 600, which is pretty good for a blog post, especially when you're looking at it on a retina screen. And the results of that post are right here. It's a simple bar chart. You can see it's somewhat uniform for the older posts. Got the x-axis, the years, y-axis are in percents, and all the labels are as expected. And that's how ggplot2 works. It's pretty simple once you look at it, and even some of the more advanced examples are just variations of this. If you want to include like a notebook, I recommend using the markdown image format. And that's, in my opinion, works better than natively embedding the image itself into the notebook. And now let's get to the hard part, which is querying all the question data and then doing some analysis on that. For this post, I did a two-step, which in retrospect wasn't as smart as I thought it would be. First thing I do is modify the answers question, the answers data set from the December 2017 snapshot, which has features you expect. It has the creation date, a mapping to the question the answers responding to, and the score of the comment, and also I engineer a few new features using window functions, which are the fun part of SQL. Using the partitions, I calculate like whether the questions, the first question, the second question, the first answer, the second answer in response to a question, and scores the highest score, the second highest score, etc. And also use a count trick to create enough answers without having to do a separate aggregation. I'll be reusing this in order to join it to the questions data sets. I take the questions data set naturally. I join the answers data set derived above, filtering on the first question to get the meta features for the first question, and I also join on the actual correct answer ID for the given question to want to get more metadata on the answer. Then I pull a lot of features. I explicitly coerce the creation dates to date time because BigQuery has enough timestamps, and if you export a timestamp, it will not import well as a date time. So I force it to do that. BigQuery, it takes about maybe a minute to run. It's a relatively fast query. That's actually pretty nice. And in order to get that much data out of BigQuery, I export the table to the Google storage and then download from there. And it's about 400 MB, so I just don't store it in the same directory and just load it manually. And here we go. It sees a lot of data. R can automatically infer the schema. That's actually pretty nice. And all big cool feature about RStudio is that all the features, all the variables are stored here, and you can click them to get a more detailed view of the data itself. And also keep in mind, you have 2.3 million here, 2.3 million questions, and this is not big data. This is a normal computer. I'm not running this on the cloud. Big thing is you can click that, and you can look at the data itself. You can see you got the ID, you got the question title of the question, we got tags nested. The nesting's important. Got the creation date. This is UTC. We get to that. The accept the answer ID, which I use for the joins. More information about the accept the answer ID. I have the creation date of the first question, the information for the answered question, and also the time in seconds. The seconds is key between the first answer and the time for the accepted answer. And I'll add a few columns here. I mentioned the time is in UTC, so we'll convert that to Eastern to keep things simple. These are all lubricate functions. The hour posted extracts the hour from this new time offset timestamp. The weekday posted extracts the weekday name, like Sunday, Monday, Tuesday. The week posted uses floor date. It flows to the newest week for the question, which is good for aggregation. And same thing with month posted. And here now add a few new features, which I don't actually use all of them in this post because I got carried away. The number of answers. If a question had no answers during that join in the query, it'll be null. So check if it's null. If it is, there's no answers. If it's a Boolean. If there was an answer and if it was within less than an hour, check that. Number of tags is I use a little trick. If you saw back here, the number of tags is delimited by a pipe. So the number of tags is number of pipes equal to number of pipes plus 1. And so I use stringer, which is a part of tidyverse. Keep in mind that pipes are special characters with regular expressions, so I have to split that before I can do that. And then is answer. This one I do use a lot. Check to see if the time until answer is defined. If so, it's 1. If so, 0. And now we can go. Now we got the ETL out. Let's do some fun stuff. Here's another simple aggregation of using this week posted truncation. You use that def, just count the number of entries at that given week posted. G on bar, use Stack Overflow colors. Use scale date time, not date this time. Do it 2 months. The B is the B format is the 3-letter month name. Scale Y using a comma instead of %. Then then everything's simple there, and then the result is here. That's pretty simple. You can see trends are about consistent. And now we get to the crazy part, which is unnest tags and unnesting them. So as you saw here, I have tags. I want to split them and be able to analyze like tags across all 2.3 million questions, and that requires a smart data workflow. If you do that in Python, it might be a little messy, but R has some interesting tricks. Although I'm getting ahead of myself. The first one is just using the number of tags. Oh, hold on, I didn't actually run this code. I should do that. The code may not be. Since I'm recording in 4K, code will run a little slower. This num tag is actually pretty slow. Because it's not vectorized. I'll apply, which what it would do is count the number of instances, and then for each of 2.3 million, calculate how many it found, and do that. Going back down. Then after all that ETL, this changes. So I'll reload. So you got number of tags, 2, 3, 4, 1, 2, 3. In Stack Overflow, it can only be between 1 and 5. So what I do is some dplyr aggregation. Dplyr part of tidyverse. So if I group by tags, I'll group by the 2, group by the 3, group by the 4. Then summarize it, which will count the number of of entries in each of those brackets, and then the percentage answered. I sum the number of is answered because is answered is between 1 or 0, then divide by the count to get the percent that's been answered. I de-aggregate, and then I also want to calculate the percentage of all posts under that tag. Because then I do normalize again like I did with the first visualization, and then sort by the number of tags. The result is something like this. You get a count. You can see percentage is about the same, but the percentage answered, it's very close between all tags, so that implies the tag count doesn't have a big impact. And yeah. Then now just create this visualization. I'm using stat identity again, but I'm using factor number of tags. Otherwise, they'll treat this as a numeric, and you don't want that. But I'm going to do something different with the colors. I'm going to going to fill on the same attribute as y, and then with that, I'm also going to use a color scale instead of using the Stack Overflow color. This scale color Viridis. The Viridis is color friendly palette, and the default is a blue, green, yellow. I like Inferno. I think it's cooler. Limits to force it between 0 and 1. If you don't do that, it'll just scale between this, and that'll be unhelpful. Guide. I don't need a helper for that and this. And then also the geom text, which will applies a text near it. And then I format that text as a %. Just like the chart itself, and then offset a little bit so that text will appear above the bar. That gives a little visual annotation. A few more themes, then you get something like this, which is not too bad. It's not the text is not strictly necessary. The color filtering, the filling is not strictly necessary, but it looks cool. It's not that difficult to implement, so why not? Now I'm going to get to the fun tag parts. So, see, just selecting some tag and some relative metadata. Now, the cool thing is unnest tokens, which is a part of tidy text. What I want to do here is see back with the tags, it's unnested. So what I want to do is, like, for example, if I unnest this, it'll create 2 rows that contain like this row for JavaScript and a row for jQuery containing the relevant metadata. And with that, I can aggregate that nesting and find some relevant statistics on those tags. So for example, in order to unnest, I have to do that split by the pipe again. You can do that with stringer. Then aggregating that, I can calculate relevant summary statistics like the count, the median score, median answers. These are both 0, these are both unhelpful because it's skewed, and then percentages answered for each of those tags. Arranged by the count, and just to keep things sane, I only look at the top 1,000 by count. And it'll be a little slower as far as things go, but keep in mind I have 2.3 million, is about an average about like 2 to 3, so that's maybe 6-7 million in memory. And I have to be a little bit careful with the constraints. Here it is. Plus the data, and see all these. Nothing is inherently inconsistent. These are all like new technologies, very popular technologies. That's great. At the bottom, you can see very unpopular technologies. All right, go deal with that. And then here's a variant of that but also keeping, well, the first, for example, this is sorted by popularity. The top 40 tags will be the same top 40. But in this case, I want to keep the month posted intact, so I can do aggregation on that. So it's the same thing, except sorting by month posted and keeping that. That'll affect the aggregation a little bit. But here's the keys to filter. I want to use this top 40 from here. And then keep that. There's nothing technically stopping me from using more than 40. I do that just to keep the analysis somewhat sane. And now you can go visualize all that. Like the previous aggregation before. I aggregate by month instead of by week. Count. I'll be filling with the tag. I again use the alpha equals 0.9 identity. the geom smooth. This adds a trend line. I want to use a linear trend line because a non-linear trend line would look a little ugly. Scale daytime, I'll do 3 months. But the key thing is this facet wrap. The facet wrap will add a separate chart for each tag, and as a result, it'll be 10. It'll be 4 by 10. I guess I should get the other row. The scale's free Y, so it'll be normalized. The scale will be normalized, and the Y-axis will reflect that. And times it'll show you what. It's a very cool thing to do, just with a little bit of code. And here it is. So we got a chart for each of those top 40 tags, and got the date times. See big trends. See Angular is doing the opposite of AngularJS, probably related. Pandas and R are data technologies. They're going up way fast. Ruby on Rails is going down. React, unsurprisingly, is going way up. And that's all there is to it. Just it's only one line code for 40 split, not even for loop. All right, now we get into some crazy things. One of the plots I really like is doing heat maps of posting times. So I do the same thing. I already format the hour and weekday posted, and then do a similar aggregate. Except in this case, I'll have to normalize as well after the aggregate to get proportions, so that each heat map for each of these 40 facets will be on the same scale. All right. The tool I use there is GM Raster, which is, if you heard of GM Tile, it creates like that, except GM Raster is a little bit faster, which is relevant when you're drawing a ton of heat maps. Scale discrete. I do the Viridis again. I do a lot more theming because I have to, in this case, I have to have a legend, otherwise the chart would be hard to read. And the cool thing is the geom V lines. In the post, talk about looking at 9 to 5s, 9 a.m. to 5 p.m. And so I do that, use the corresponding hours representing those values. So let's use what you get. Not too shabby. See different trends. Sometimes it's within, like with Pandas and R, but most of the time it's outside these bounds, and that's all there is to it. Now, tag distributions. This one's a little tricky because in this case I do not want to aggregate. I want to keep it in memory because I'll be needing those distributions for other things. So that's essentially all that's done here. Let me run this code. So I'll be using this a lot. And because in memory, I want to be very careful about the features I use. Even though this computer has 16 gigs of RAM, I don't want to go over it. In this case, it adds 250. Let's open that to see what that's all about. I've coasted, see it's denested. You can see that these like correspond to the same one. That's that. The medians, I want to get the order of medians because that might be helpful in the future for visualizations. And then I want to change the factor levels for plotting so that they correspond to these medians. And I also reverse the factors using forcats from Tidyverse when I want to do the line chart. Do bar charts in descending order. So speaking of bar charts, in this case, I originally has as box plots, but they're hard to read, so I wanted to try a joy plot, which is a new data visualization that got a lot of popularity. But it got changed to the Ridges package because I think joy might be copyrighted. Using geom density ridges, just run that. Everything's kind of the same. It's not too. I do scale log 10. Right. I should say I want to do view count for each post because why not? Scale log 10 because view count's skewed. Always like that. Force limits in order to prevent the charts from going too wild. Since it's on log 10, I want to have to use like log 10 limits. Besides that, nothing too weird from that. And the result. Get over here. Result is this. Which is probably, I admit, it's more pretty than functional, but I have no issues with that. It's much better than the box plot, trust me. And you get that distributions are kind of the same. That's helpful. And sorting from the top median that I did using this factor sort, Angular and Firebase do get a slight edge, but again, the overall distribution is the same. Oh, and this is what happens when you don't specify the top. Bad things happen. And now for the really weird shit, we do have the tag word cloud, in which case I unnest twice. And I actually have to filter it between the top 20 because it was too readable with just using the same top 40 I did for the ones above. So then once you unnest the tokens, you have to unnest the titles in each token. Tidy text contains a words tokenizer, which is helpful. I then filter out the stop words included with tidy text. And then just do the same aggregation, aggregate the count of words for each tag. Then normalize that count, and then keep the top 20 words by that particular count in order to prevent the word cloud getting too robust. This one will probably take a little bit longer. But yeah, this like I believe this word cloud is like major concern about like forcing it to only 2.3 million, because if you're doing a full data set, it'll scale a little bit nicely. So you have the top word for the Android. It's Android by margin, not surprising. Go scale through here. You got Angular top words. Nothing that too surprising. Now here's a word cloud trick. That's not mine. I found it by Mahari McNeil, and it's a very clever trick. The trick is use geom text repel to just like put all the words in the same spot and then let them fight it out. I set the size and color to max norm, so more words, more usage will appear bigger and in different color. Scaled size, just to keep it from being, just to maintain readability. I use Viridis. I ended at 0.8 because the higher ends are bright yellow, and that's very hard to read. And then I do the same faceting. I remove the axes, and putting it all together, I get this, which turned out better than I expected, which is a trend with a lot of my ggplot2 data visualizations, to be perfectly honest. It got important words for each one, and it should still be readable at like mobile, on a mobile browser, which is the big constraint with a lot of my data visualizations. Alright, doing that, I want to find a distribution of times, just so I use that big distribution with all the times, and then just find the median of that, and sort by that median. It means PNS is fast, followed by arrays. These are on seconds, so this is about like maybe 15 minutes ish. That's faster than I'd expect. So then this is going to do histogram. I have to filter the data a little bit. This got a little over messy, and I apologize in advance. To filter the all day distribution, so you can calculate histograms of the whole distribution. I add a V line with this median, and then here somewhere I sort it by median, by this median. So the facets will be from smallest to largest. Because it's on seconds, I want to do it in hours. If you scale to this, start getting the hours territory. Then using that. Right, so it's 0 to 4 hours. The label is 0 to 4, but the actual functional breaks are between the hours seconds when converted to hours. Doing the same things. Then running it results in this visualization, which is not too shabby. You can see that it's a little bit of a power law. You can see distribution flattens a little bit. There's a lot more than 4 hours, which is why this doesn't isn't a perfect 50-50 split. But you get the idea. And there is an error. I'm not entirely sure why that error happens, but it happens. All right, I tweak the top tags distribution a bit. And then one more thing I want to do is find the best and the worst languages by the answer rate, because that will vary significantly by time. Again, reaggregate by the median times again. This is probably redundant. I may have coded this out of order, which happens, but oh well. I'll avoid it in the future. Okay, all right. I want to do the top 30 for readability, so I filter these into the top 40 with the head, and then do similar things I've done with the bar charts. I do chord flip, so the labels, so it's a bar chart, especially a column chart. Then just do similar things like that. Nothing too weird that you've seen all the time. Okay, then you get this, which makes a lot of sense. A lot of new technologies with big user bases. Then I also do the inverse. Basically copy and pasting everything from here except changing head to tail, so it does the last ones, and then changing the labels. Doing that. See? I also keep going for the scaling. It did from between 0 and 1, so the percents stay like that, and that works out great. Alright, lastly, I want to do the adjacency matrix, which is probably the weirdest one out of all of these in terms of ETL. If you're familiar with the graph network, I want to find like the edges and aggregate them. I do essentially that for this adjacency matrix. To do that, the distributions, I kind of join it on itself. Yeah. Take the top 40, take the less tokens, and then join it on like the same question ID, so that I'll calculate an inner join, not just left join, an inner join. So I'll calculate all possible pairs of tag X and tag Y. I don't want dupes, so I filtered those out. Then for each pair, I want the count, the total answered, and then the percentage answered. And then putting that. You can see you got all the pairs. It's symmetric. I don't remove the dupe and the symmetric dupes. That's intentional. You got the count, and then the percentage answered. All that here, and then you can see like for a lot of them, I don't have a lot of data, so I will be filtering to only pairs with greater than 1,000 Anderson common, and that right here. And then now we can go visualize. It's another, like the heat map, actually pretty much the same thing. In this case, just want to find a count, the scale log 10, and then that's actually pretty much it. That's the easy part. It does take a lot of formatting to get the chart into the correct spot. And then see, it's symmetric, but you can see a lot of pretty charts all around. Big things are jQuery and JavaScript, which makes 100% sense. Right, and lastly, I want to do more of those percents, which is the same thing. I just set to fill to percent answer. I scale the fill by percent. But one thing I decided to do that was a little bit cool is add text onto it, which represents percent and allows it a little bit easier to see at a glance, like the relevant percent. I do sprintf, which is the special point format. This just forces 2 digits, and I use a condensed font, so I have a little more space to work with that. Same thing. And here you go. Got the text is on top of it and represents each percent, and there you go. That actually worked out better than I expected, anyways. Which is again the case with Llama ggplot2. And that's it. I hoped you learned something interesting, and I hope I didn't ramble on too much. And as you can see, there's a lot of data I didn't even use, but collected anyways. So there's a lot more to do with our ggplot2 and all the Stack Overflow data. And if there's enough interest, I'll give it another look and see what other cool things I can do about it. And again, I'm Max Wolf. Please like and subscribe to my YouTube channel. Please follow me on Facebook and Twitter. And if you like this video, please subscribe to my Patreon. Anything my Patreon will be used toward deep learning, towards bigger data sets, and other cool things, which will definitely be put, and the money will definitely be put to good use. See ya.